Hi, welcome to physics course on non-destructive testing of the materials. Testing of material is imperative part of the quality assurance. For first year engineering, following is the syllabus where we will study different entity methods and their advantages, and three different entity methods we are going to study. One is ultrasonic testing, UT, radiographic testing, RT, acoustic emission technique, AET. The objectives of NDT are the quality assurance, TPM, that is total productivity management, more improved designs with the help of the non-destructive testings, and the value for money, of course, customer satisfaction. TPM is related to finding the critical operations, preventing the failure of the machines and the components, saving man-machine material, in-service testing. All these are related to TPM, and non-destructive testing is helping in boosting all these particular operations. There are two well-established testing methods. One is destructive testing and another is the non-destructive testing. In case of destructive testing, there is testing by destructing the material, whereas in case of non-destructive testing, the material is tested without its destruction. And that is why material can be used after testing also. That is one of the most important advantages of this non-destructive testing. Generally, the properties of the material, like mechanical properties, chemical, thermal, etc., are possible by making use of destructive testing. However, once material is tested, it has to be thrown out. But in case of non-destructive testing, it is mainly employed for detecting the disorders or say faults like crack, flaws, foreign material, etc. The well-known destructive testing methods are stress test, hardness test, toughness test, fatigue test, etc. For non-destructive testing, we have these VT, PT, MT, UT, RT, AET, ET, etc. One should take into account that any type of fault or say disorder is inherent to that particular manufacturing process. For example, whenever we are talking about fabricated component, that is welding component, it is inherent that lack of penetration, flaws and cracks will be there. For forging component, these two types of faults like channel and laminations are possible. For molding, porosity is inevitable, and in case of turning, we have texture, etc. Types of NDT methods. There are mainly two types of NDT methods. One is surface testing, another is volumetric testing. Surface testing is generally employed to detect the surface disorders, whereas volumetric testing is for detecting the internal disorders. Now, what are the surface disorders? Some of the examples are texture, color, appearance, scratches, cracks, porosity, etc. In case of volumetric disorders, these are the air trap, void, we have this inner flaws, slag inclusion, etc. Well established surface testing methods are visual testing, that is VT, PT, penetrant testing, MT, magnetic particle testing, ECT, that is eddy current testing, thermography, microscopy, etc. And in case of volumetric testing, the UT, RT and AET are most widely used techniques. This is the table which depicts various mature methods which are used in industry and the principles of physics used for functioning these particular methods. Now these are the advantages of the non-destructive testing. Most important advantage is affordability. As we know, there is no destruction of material, means no material wastage, no man-hour wastage, and the processing what we are going to do will be avoided as prior information about faults can be known. So man, machine and material cost can be saved. Another important advantage is reliability. The results which we are going to seek from this particular testing methods, they are accurate and they are precise. One can rely on that particular, so it is more reliable. Again, except radiography, most of the testing methods are safe, non-hazardous. Again, we have here peace of mind. That is one of the indirect advantage of this non-destructive testing, because in that way we are getting guarantee of the sufficient life of the material. The disadvantages are related to these particular things. It's a relative technique. So one should know the standard results to predict the results of this particular test. We have the expertise which are required for understanding the test and conducting the test. Calibration of the instruments in case of the ultrasonic testing is widely required. So knowledge of calibrating the instrument is must. Minimum 2 tests are required for understanding the complete information. Again, whenever we are talking about any NDT method, it may be RT, it may be PT, it may be UT, it may be any NDT method. It can have these 4 components. The first component is probing system. It is related to the medium which is used to probe the faults. The second is the detection system. Some sensors are used to detect the faults or the disorders, and these disorders will be shown either on the screen or in the form of some pattern. It is known as indication. So indicating system is also required. And the fourth point is nothing but interpreting these particular results so that we can give the guarantee of that particular material. So interpretation may be computerized, may be manual. Now turn over to the first method that we are going to study. It is ultrasonic testing. Ultrasonic testing is a volumetric testing. Whenever we are talking about probing medium, detection system, indicating system and interpreting system, how we can correlate these particular components with UT. These are probing medium is nothing but an ultrasonic wave. It is high frequency sound wave. Detection system, where we are going to use ultrasonic transducer, that is piezoelectric transducer. Piezoelectric crystal can be used to detect the sound. And next is the indicating system. This particular ultrasonic transducer, this particular ultrasonic wave which is reflected or transmitted will be considered or will be recorded as an interpretation or as a pattern of that particular sound. Next is the interpreting the result. The results can be interpreted automatically, or it can have the calibration and all those things. The basic principle of the ultrasonic testing is nothing but a sound reflects when there is change in medium. In short, when there is a disorder in the path of sound, means change in medium that will be recorded on the screen as a reflected sound. So disorder can be recorded as a reflection of sound on the screen. The following figure is giving you the details of the construction of this particular method. It consists of this part, it is known as piezoelectric transducer. For this particular method, this transducer is acting both as the transmitter of the sound wave and also as the receiver of the wave. This particular wave is sent through this particular material, that is specimen. Whenever it is not encountering with any disorder, in that case we will get this particular first peak, and this first peak is from the front side, whereas this particular peak is from the back side of this particular specimen. When this particular sound wave is encountered with this crack, at that time one more peak will be observed, and that is related to the crack. So this is front echo, back echo, and this is crack echo. In absence of the disorder, we will be observing only these two peaks. Having distance equal to EP, it is equal to thickness of this particular material under testing. With the defect inside like this, the light is going to reflect not only from the front and the back surface, but it is also going to reflect from this disorder. So one more peak is going to be there, and that is how we can say that without a defect we will have only two peaks, front and the back. And with the defect, in addition to this front and the back echo, we are going to observe one more peak, it is with respect to the disorder. By using this particular method, we can calculate the thickness of the material. Not only that, but we can locate the disorder from any of the sides of this particular system by just using this formula. Distance is equal to velocity multiplied by time. In this case, the distance traveled is 2 times the thickness, and that is why distance is equal to 2 into velocity into time. So the distance from front side or say back side can be calculated just by knowing the thickness. This was about the pulse echo system, but there is one more system, one more orientation, where instead of using reflection of the sound, one can use transmission of the sound for understanding the disorders in the material. So only difference is that in case of pulse echo we are using reflected sound, whereas in case of transmission method we are using the transmission of sound. That's it. These are the advantages and disadvantages of the UT. Most important advantage is that you can use ferrous and non-ferrous materials for testing. Just by increasing the frequency of the sound, you can have the increase in the depth to which you can have this identification of the faults. Disadvantage is that generally it is used on the finished surface. Irregular geometrical surface or rough surface, rather it is difficult to conduct the test on this. And these are some of the advantages and disadvantages that you can go through. Next method is radiographic testing. It is also volumetric testing because it is also used to determine internal faults from the material. Whenever we are talking about this probing, detecting, indicating and interpretation, now we'll try to correlate. Probing is related to either X-rays or say gamma rays. These are the high frequency light radiations. They have high penetrating power, so they can penetrate to the material and can come along the information, internal information of the material. Detection system is generally photographic film or say fluorescent screen. Indication is in the form of the geometry of the image recorded. Whenever we are talking about elongated indication, it may be a crack. Whenever we are talking about a round indications, it may be porosity. Interpreting results can be done just by making the manual observation, or you can have the computerized interpretation. This is somewhat the construction of this particular conduction of the test. The principle behind the RT is nothing but an internal image of the material can be captured just by passing the X-rays or say gamma rays. Here this is X-ray tube or say gamma ray source. The light or say gamma rays is allowed to fall on this particular material, of which we are going to test the internal structure. Whenever there is change in the density or whenever there is fault inside, that fault will be recorded as an image on the photographic film. So this is something about the observed fault. This observed fault is having less density, so it will be recorded as a high intensity of light and the rest of the part will be rather dark. So disorders are recorded as image on the photographic film. That is most important aspect of this particular radiographic testing. What are the advantages and disadvantages of the RT? Most important advantage of the RT is that you are not required to clean the surface. Without cleaning the surface, you can conduct the test, and the test results or records can be preserved for the future reference. RT is possible in case of any shape of material. Most inevitable the disadvantage of this RT is nothing but it is hazardous. So care should be taken and well-trained persons are required to conduct the test. There are another two methods in which this RT can be conducted. Instead of using single exposure, you can expose this material from two different places, and this is known as the displacement method. Again, instead of using photographic film, one can use fluorescent screen, that is CRT, cathode ray tube, etc., to record the results. So what is the difference between the radiography and the fluoroscopy? In case of fluoroscopy, fluorescent screen is used. In case of radiography, photographic film is used. Whatever the image which is recorded is on the photographic film, and here it is recorded on the fluorescent screen. You can observe that high resolution and the contrast is possible in case of photographic film. That much resolution and the contrast is not possible for the fluorescent screen, but immediate results are possible in case of fluoroscopy, whereas some time will be required to get the results from that particular radiography. Radiography is rather expensive and fluoroscopy is inexpensive. Now turn over to the third method. It is acoustic emission testing. It is AET. Again, we'll try to understand the different components of this particular AET. Probing. In this case, probing medium is nothing but a stress wave. Detecting system is related to the piezoelectric transducer or say sensors. Indicating is in the form of pattern which will be observed on the screen, and interpretations can be done either manually or can be done with the help of computer. The principle behind the acoustic emission testing is that when material is loaded, stress waves are generated, and just by knowing the nature of the stress waves, disorders can be identified. Again, this is nothing but a schematic of this AET. This is the test component. It is loaded, from these two sides, or it is the stress is applied on these two sides, so that there will be a displacement of the molecules, and that is going to produce the stress wave, and the stress will be captured by this particular sensor. The stress wave is very weak, and that is to be amplified by using this amplifier. After using this amplified signal, the signal processor which is going to be used over here, and that is going to filter out the unwanted noise, so that the clear signal which is given by this particular material can be observed on the screen. These are the observations. As an example, I am giving you here the burst emission type of pattern and continuous emission type of pattern. In this case, only once the emission is given, whereas the recurring emissions are given out. This burst emission is related to cracking, related to solidification, related to sudden fracture of the material, whereas this continuous emission is related to the recurring stress which will be observed on that particular material. For example, the recurring stress is possible in case of the friction and the leakage of the crack surface. Advantages of AET. Real-time testing is quite possible by using this AET, because it is not required to shut down the machine for testing. So without stopping the function, you can test the component. That is the beauty of this particular AET. Therefore, such a type of technique is widely used in testing the breeze structure, process equipment in chemical industries, sugar industries, etc. The disadvantage of this is, one of the inevitable disadvantage is that noise will be there, and that is required to be filtered out, so that clear structure of this particular pattern can be observed. This is something about non-destructive testing of material. So UT, RT and AET, these are the methods in your course. You have to study this particular advantages, disadvantages, etc. So in short, to conclude, NDT is nothing but it is the process of testing the material without destruction. As there is no destruction, it has advantages with respect to saving man, machine and money. Again, one of the disadvantages is that it requires expertise, and as it is related to technique, the standard result should be known while conducting the test. The three methods, these are very important, that is UT, RT and PT. Any NDT method can be explained under the four components, and these four components are probing medium, detection system, indicating system and interpreting system. So thank you.